Step to find rank. How to find the rank of a matrix? First is reduce the given matrix to an row echelon form and then find number of non-zero rows. That will gives you rank of a matrix. Find the rank of the following matrices. How we can find it? We can check whether the determinant of given matrix is equal to 0 or not. If it is non-zero, then directly you can say the rank of this given matrix is 2. So you know the method, so you can find out the rank of all the given matrices. I will share all these examples with you so you can practice for it. Now, remarks or some result related to rank. For a rectangular matrix A of order m cross n, then rank of a matrix less than equal to minimum of m comma n. For example, you will be having a rectangular matrix 1, 2, 3, and 4, 5, 6, 7, and 8. 2 rows and 4 columns. Right? So what maximum rank can be for this matrix? So you can write rank of a matrix is less than equal to minimum of this. What is the minimum? That is 2. So rank of this matrix can be equal to or less than minimum of number of rows and column. So when you will find the rank of this matrix, the maximum rank would be 2. Right? Next, for a square matrix A of order n, rank of a matrix is equal to n. A rank of a matrix is equal to n if determinant of that matrix is non-zero. A matrix with non-zero determinant is known as, who will tell me? A matrix with non-zero determinant is known as,
Ma'am, non-singular matrix.
yes, it is non-singular matrix. So if rank of a given matrix is equal to n, it means that matrix is non-singular matrix and determinant of that matrix is not equal to 0. And if rank of a matrix is less than n, it means that matrix is your singular matrix. Because it is less than n, then it is sure that determinant of matrix of order n is equal to 0. Right? So rank of a matrix n, then square matrix is said to be non-singular, otherwise singular. Every non-zero matrix A is of rank greater than or equal to 1. Let us having a matrix whose one entry is non-zero and rest of the entry would be 0. Right? So what can be the rank of this matrix? Anyone? This is a non-zero matrix, right? Because of presence of this one, this matrix is non-zero matrix. So what will be the rank of this non-zero matrix? Tell me, hurry up.
1.
1. Rank
1.
of this matrix,
Ma'am, 1.
A, right. Rank of this matrix is equal to 1. Right? So what is this remark is saying? Every non-zero matrix A is of rank greater than or equal to 1. This is the worst case. जब आपके पास एक entry non-zero है, ठीक है, एक से ज़्यादा होगी तो rank would be greater than or equal to 1. So let us say I am saying this entry is your 2. Now what will be the rank of this matrix?
Ma'am, 2.
Yes, rank of this matrix is 2 because it is already in echelon form and number of non-zero rows are 2. So every non-zero matrix of matrix A is of rank greater than or equal to 1. And if you're having null matrix means all entries are 0. So rank of null matrix would be
So 0.
0, right? So the rank of null matrix is always 0 because सब चीज 0 है and number of non-zero rows that is 0. So therefore rank of null matrix is always 0. Rank of a matrix and rank of its transpose both will be same. You can verify it. You take one matrix, find its rank, and then take its transpose and find its rank. Both will be same. Rank of product of two matrices cannot exceed the rank of either matrix. You will have one matrix A, right, and another matrix B. You'll be taking their product, and then rank of product of these matrices cannot exceed either of matrix, means it cannot be more than rank of A or rank of B. दोनों के rank से ज़्यादा नहीं होगा, right? Rank of A plus B less than equal to rank of A plus rank of B. When you are adding A plus B, and then if you'll be finding the rank of A plus B, that would be less than equal to rank of A plus rank of B. Right, so these are some remarks related to rank. You need to remember all these remarks. You can note it down, beta. Find the rank of this matrix. Everyone knows the rank of this matrix would be 1 because this complete row and this complete row can be 0 with the help of row operation. R2 implies R2 minus 2 times of R1, and R3 implies R3 minus 3 times of R1. Right? So this becomes 0, 0, 0, and this is become 0, 0, 0. So only one non-zero row would be there. So rank of this matrix would be 1. Right? So you need to verify all these remarks. Right? You will be taking matrix A. I will provide you in this slide. Matrix A is represented with A in question number 4. So you will be finding A plus B, B plus A into B, B into A transpose, and then find the rank of all these, and then check these remarks. Right? Now, come to the next. Gauss-Jordan method. This method is used to find inverse of a matrix. Right? Gauss-Jordan method is used to find inverse of a matrix. What is the condition to find the inverse of a matrix? Tell me, anyone? What is the condition to find the inverse of a matrix?
Ma'am, it shouldn't be a null matrix.
And we have to
It should
make the
not be.
given
Null
matrix and
matrix.
ident.
No, beta. I'm not asking about the Gauss-Jordan method. I'm asking about for which matrix you can find the inverse.
Identity.
M square matrix
Matrix should be
Square matrix.
or
or by
matrix should
M
be
cross M.
non-singular. Determinant of that matrix should not be equal to 0, right? Let A be a non-singular matrix of order n. If matrix is non-singular, then only you can find its inverse. Then matrix A can be written as identity matrix into A. Using elementary row operation, we can reduce this identity matrix, this given matrix into identity matrix, and corresponding to these row operation, whatever matrix you are getting at the place of this identity matrix, it will give you inverse of that matrix. Right? Using elementary row operation, we will reduce this given matrix into identity matrix, and corresponding to those operation, whatever changes would be there in this matrix, that will be your inverse of a matrix. Right? So Gauss-Jordan method, you can find the inverse of a given matrix using elementary row operation. No column operation would be there, only row operation. Why row? Because when you are representing A is equal to identity matrix into A and identity is written prior to given matrix, then you can apply only row operation. Right? Let us have an example. Find the inverse of a given matrix using Gauss-Jordan method. This is your given matrix. First step, write the given matrix in the form of A colon I. 1 minus 1, 2, 3. This is your given matrix. Column, identity matrix of same order 1, 0 and 0, 1. 2 cross 2 order. Why I am writing this in this form? I told you you can write a given matrix of identity into A. Right? Our task is we need to apply elementary row operation and convert this matrix into identity matrix, and corresponding whatever you are getting here, that would be your inverse matrix, right? So we can proceed in this way also, but sometimes what happened when we proceed in this way and we will apply the row operation to convert the given matrix into identity matrix, somehow it happens sometime we forgot to apply the same operation on this identity matrix. Right? Because we need to apply it simultaneously. जो ऑपरेशन आप यहाँ लगाओगे वो ऑपरेशन यहाँ भी लगना चाहिए. But when we write it in this form, तो sometime it happens कि हम यहाँ लगा देते हैं and we forgot to apply on this matrix. Right? So somehow it become wrong. So for sake of this thing कि हम इसे ना करें, we will avoid this thing. So you can write given matrix in this form, A colon identity matrix. Right? When you will write in everything in the form of matrix, then chances of doing mistake will be very, very less. So this is your given matrix 1, minus 1, 2, 3, and then corresponding identity matrix 1, 0, 0, 1. Now your task is you will convert this into identity matrix using only elementary row operations. Right? So for making identity, we will make this entry as 0. Right? So we will make this 0 with the help of R1. So you will be writing here R2 implies R2 minus 2 times of R1. R2 implies R2 minus 2 times of R1. After applying this operation, you will be getting this. Right? To make it identity, I need this entry as 1. So what you will do? You will multiply this row with 1 by 5. Right? So you are doing so. After doing this, you will be at this step. Now, for identity matrix, this entry must be 0. So you will be writing R1 implies R1 plus R2. R1 implies R1 plus R2. So after doing this, you will be at this step. Now this given matrix has converted into identity matrix, and this corresponding matrix will give you inverse of given matrix. Right? So you can write here A inverse is equal to 3 by 5, 1 by 5, minus 2 by 5, and 1 by 5. Right? So for verification, you can check given matrix, A matrix, and A inverse, which you have evaluated. Check whether their product is identity or not. If it is yes, that means your answer is correct. Right? Is it clear, beta?
Yes, ma'am.
Okay. Now, let us have one more example. Find the inverse of given matrix using Gauss-Jordan method. So this is your given matrix. You need to find out inverse of this matrix. So again, first step, you will write given matrix in the form of A colon identity matrix. So this is your matrix A colon identity matrix of same order. So this is 3 cross 3 identity matrix. Now you need to start. So if I'm making this 0 or this 0 with the help of R1, so you can do it, right? If directly you will start your question, then question or all calculation will be in fractions. So it's your choice whether you want to go with the fraction or without fraction. So my preference is go by without fraction. So what we are doing, we are making 1 at this place, right? We are making 1 at this place. So you can write either of operation, maybe R3 implies R3 minus R2, or you can write R3 minus R1, whatever you want, right? There is no issue. So let's see what we have applied. We have applied R3 implies R3 minus R1. So after R3 minus R1, you will be at this step. After calculating, this is your new row, third row, 1, 1, minus 1, colon, minus 1, 0, 1. Now what will we do? We will interchange R1 and R3. We will interchange R1 and R3. So let us do it. R1 and R3. Now, for making identity matrix, I need first entry 1, that is done. Now, next 2 entries would be 0, right? So from making these entries 0, you will apply R2 implies R2 minus 2 times of R1. R3 implies R3 minus 2 times of R1, right? After applying these operations, you will be getting this matrix. 1, 0, 0, 1 minus 1, 0, 5, minus 5, 5, and corresponding whatever changes will be there, that is represented by this matrix. Now, what is next? I need here 1, right? So you can see that if I'm multiplying this with minus 1 by 5, so it would become 1, and then I can interchange row 2 and row 3. So first of all, what we are doing, we are multiplying this R3 would be multiplied with minus 1 by 5 R3, and R2 can be multiplied with 1 by 5 of R2, right? Or if you want to interchange first and then multiply, you can do it. So here we have interchange first. So let us interchange, right? Interchange and then apply this. Now we will multiply R2 with minus 1 by 5 and R3 with 1 by 5. So ultimately you are at this step, right? Now what is next? This entry must be 1, it is 1, it is 0, 0, 0, 1, 1. That's all. Now the problem is with these entry. We need to make all these 3 entries as 0. So now what can we do? You tell me what can be your next row operation for making this entry 0. Tell me. Anyone?
Ma'am,
Not Shubham.
R2 equals
No
to R2.
Shubham.
What, ma'am?
Shubham, no,
R2 plus
please.
R1.
Anyone else? Anyone else? Vanshita. Vanshita? Okay, Anurag. Anurag, are you there? Okay, Abhishek. Abhishek, are you there? Am I audible?
Yes, ma'am.
Yes,
Yes.
ma'am.
Okay, means
Yes, ma'am.
they are not responding, right? Aryan, Aryan, Harleen, Harleen. Okay, Hitesh,
Yes, ma'am.
please better tell me what operation we can use to make this entry as 0.
Ma'am, R2 implies
Mhm.
R2 plus R1.
R2 implies R2 plus
R1.
R1. Sure,
R3,
beta?
ma'am, sorry. R3, R3. R3,
Why
ma'am.
not? Why not R1? Tell me, beta, why not R1?
मैम R1 से भी कर सकते हैं.
कर सकते हैं? Sure?
Yes, ma'am.
Okay. So if you are writing R2 implies, now Hitesh, you will tell me, बच्चे. R2 implies R2 plus R3. Now do both the calculations. दोनों कैलकुलेशन जल्दी से करो और मुझे बताओ, should I go with this or this? Should I go with R3 or R1?
Okay, ma'am.
Do it, hurry up. Meanwhile, Kshitij, are you there?
Yes, ma'am.
Beta, can you tell me out of these two operations, which is best?
Now may I?
Tell me your name first. Who is
Satvik.
asking, may I?
Satvik 5038.
Karthik. Yes, beta, please. Tell me, beta.
मैम R3 वाला मेथड अप्लाई करेंगे.
Why?
मैम अगर R1 करेंगे तो मैम जो एलिमेंट A22 है वो 2 बन जाएगा.
822 element 2 बन जाएगा.
मतलब
Very
2.
good, beta.
यस.
This is what I want to tell कि after making, very good बच्चे, after making these entries as 0, you need to make this entry and this entry as well as this entry 0, right? So first I'm targeting this entry. I have asked you for this entry. For this entry, right? So Hitesh told me I can apply R2 implies R2 plus R1. When you are adding this beta, R2 और R1 को आप add कर रहे हो, तो your entry would become, this entry would become what? 0 plus 1. It would become 1 and 1 plus 1, it would become 2. तो क्या हो गया हितेश? हितेश, are you getting my point beta?
Yes, ma'am.
ठीक है, these entries would be spoiled. ठीक है, to keep in mind when you need to make this entry or this entry 0, when you are going the upward things making 0, then always use this row R3 for making this entry as well as this entry 0. Use R3. Why? When you are using this R3, because of these zeros, these entry would be remain same, right? So you will be using this operation. R2 implies R2 plus R3, not this, right? So now I can apply both operation. So for making this, you will be writing R2 implies R2 plus R3. Right? Using this operation, you can make this entry as 0. Now for this A13. Again, for making this 0, you can take the help of R1. So you will be writing R1 implies R1 plus R3. Right? So apply these operation, and after that you will be getting sorry, I have told you this plus now, right? So after this, you will be getting this 0 and this 0. Corresponding, you will be applying here also. So you will be getting these entries minus 3 by 5, 1 by 5, 3 by 5, minus 1 by 5, 1 by 5 and 0. Right? Those who are getting confused while writing these entry, they can write the values on rough side, right? Let us suppose I am writing R2. R2 is what? This is your R2. So you'll be writing 0, 1, minus 1, minus 3 by 5, 0, 2 by 5, right? And then R3. So I'm writing all the entries of R3, 0, 0, 1, 2 by 5, 1 by 5, and minus 2 by 5. Right? Now add up. So this would be 0 and then 1 and then 0 and then minus 1 by 5 and then plus 1 by 5 and then 0. Right? Some students do mistake, right, while writing these entries, right? So those who are not comfortable in writing the elements or values directly, they can follow this rule, right? Just write this R2, so it is R2, write R3, then R3, add up. Now your new R2 would be this 0, 1, 0, minus 1 by 5, 1 by 5 and 0. If you do like this, then chances of mistake will be very, very less. Initially, you can do like that. When you will be in practice, then you can write directly, right? Now, this 0, this 0. Next target is you need to make this 0. So who will tell me how we can make this entry as 0? Yes, who will tell me?
R1 implies R1 minus R2.
R1 implies, R1 implies beta?
R1 minus R2.
R1 minus,
R1 minus R2.
okay. So Nitesh told me R1 implies R1 minus R2. So I just want to ask Karthik Thakur. Are you there, beta? Karthik? Okay. Ayush? 5021? Ayush? It is very disappointing. Many of students are not responding. Okay, we'll discuss after this class. Now come to this question. So Nitesh told me for making this entry 0, we can write R1 minus R2. Very right, beta. We need to make this 0. So we can make this entry 0 with the help of R2. Right? So apply this operation. R1 implies R1 minus R2. And after that, you will be getting this. Whatever operation you are applying on this matrix, you need to apply same corresponding to this also, right? Consider this complete as a matrix. So after doing this, you will be at this step, right? Now you can see that given matrix has been converted into identity matrix, and corresponding whatever result you are getting here, that represents your A inverse, right? So this is your A inverse. Now you can check your answer. Matrix given matrix into inverse of a matrix, answer would be your identity matrix. If you're getting identity, it means your answer is correct. Otherwise, there must be some mistake, then recheck your all operations and entries. Right? So in short, again I'm repeating, for finding the inverse of a matrix using Gauss-Jordan method, you need to write given matrix in this form: given matrix colon identity matrix of same order, and then apply elementary row operation, convert this given matrix into identity matrix, and corresponding whatever you are getting at the place of identity matrix, it would be your answer. That means inverse of given matrix. Please check after getting inverse, A inverse into A matrix, that would be equal to identity matrix. Right? If you are getting identity, it means your answer is correct. If not, it means you have done some mistake. I hope it is clear. Now you will practice yourself. I'll share this question with you. And after that, you will solve this question also. Your homework, note it down. Now, come to the next. Normal form of a matrix. Normal form of a matrix. A matrix of order m cross n can be reduced to the form IR0, 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 0 and 0. What is IR? IR is identity matrix of order R. Right? If you are able to reduce the given matrix into either of these form, then this is known as normal form of a given matrix. And this R represents rank of that matrix. So you can find rank of a matrix using normal form. Or it can be asked that reduce given matrix into normal form and then find its rank. Right? So what to do? You need to reduce the given matrix into normal form, and then order of this identity matrix will give you rank of given matrix. Right? So this form, or this form, all are normal form. So you can reduce the given matrix into either of this form or this also. If you are having 3 cross 3 matrix and you are trying to reduce it into identity matrix of order 3, so you can write it like this also. Right? So you need to convert given matrix into either of this form using elementary operations. When I'm saying elementary operation, it means you can use row operation as well as column operation. When I'm specifically saying elementary row operation, it means you need to use only row operation. To find the rank of a given matrix, you use row echelon form. So when it is named as row echelon form, it means only row operations are allowed. Similarly, in next Gauss-Jordan method, to find the inverse of a matrix, I have told you, use only elementary row operation. So in row echelon form as well as in Gauss-Jordan method, in both method you use only elementary row operation. But in normal form, you can use elementary row operation as well as elementary column operations. Right? So using elementary operation, you need to convert the given matrix into either of these normal form, and then R gives you the rank of given matrix. Now let us have an example. Find the rank of following matrices by reducing it to normal form. So this is your given matrix and you need to convert it into normal form using elementary row operation. You can use rows as well as column operation. So let us start. Our goal is what? This is our goal. I need to make identity matrix. I can make the maximum identity matrix of order 3 for this rectangular matrix, right? So this is our goal. So for this, you need to make, first of all, you'll try for this 0 and this 0 and then this 0. After making these 3 0, we will go for these 3 zeros. And after that, we will concentrate on this column, right? So let us start. First entry, I need 1. So either you can multiply this row 1 with negative sign, or you can interchange R1 or R3. Okay? Do whatever you like. So I'm doing operate R1 interchange R3. So R1 or R3 ko we can interchange. So let us do it. This is what equivalent matrices. Whenever you are applying row operation or matrix you are getting, so you can say that this given matrix and these are equivalent matrices, right? So operate R1, interchange R3. So we have done it. After that, you need to make this 0 and this 0. So for making this and this, both entry, we can make both entry 0 with the help of R1. So you will be applying operation R2 implies R2 plus 2 times of R1, right? You'll be multiplying it with 2 and adding up into this. Similarly, R3 implies R3 plus R1. For making this 0, you can add up these entries with entries of R1, right? After applying these two operations, you are getting this, right? This 0, this 0. Now, what next? Can I multiply this R2 with 1 by 5? R2 implies 1 by 5 times of R2. So it would become 1, 1, 4. So you're writing here 1, 1, 4. Done. And similarly, you can multiply this row R3 with 1 by 2 times of R3. We didn't get here. हमने यहाँ कुछ और operation लगाया. It's hardly matter. Anyways, you can make this according to this. You can make here 1 and you can make here 4, right? And then you can apply here R3 implies R3 minus R1, right? So abhi I'm not doing this because I need to write many more entries. So I am doing according to my PPT. It means you need to make this 0. So let us make this 0 with the help of R3 implies R3 minus 2 times of R2. Okay? Operation may varies, but please keep your funda very clear. Ki first we will make these two 0 and then we will make this entry as 0. After making this 0, right, we need to make this 0. For making these two entries 0, we will be using R3. For making this 0, we will be using R2. If this funda is clear in your mind, then there is no problem, right? And if you are choosing the randomly elements, कि पहले हम इसको 0 बना लें, फिर हम इसको 0 बनाएंगे, then definitely it would create a problem for you. Right? So please make a funda that first we will make this A210 and A310 with the help of row 1. After making these two entries 0, concentrate on this entry. Try to make this 0. And then with the help of R3, try to make this 0 and this 0. And then for making this 0, use R2. Again and again, I'm telling, please keep this funda in your mind. Don't make randomly any element 0, right? So we are at this step, we need to make this entry 0. So for making this, we are applying R3 implies R3 minus 2 times of R2. So after this operation, you will be at this step, right? So now you can multiply this minus 1 by 2. It's hardly matter. You can either apply that operation first or later, no issues. So now you are at this step. Now it is sure that it would be a identity matrix of order 3 because we cannot make this 0. Now, somehow, some student try to make it 0 with the help of this or this, right? But when you are making this 0 with the help of this and this, keep in mind these entry would spoil. And if these entry would spoil, then there is no use of applying this operation or making this entry as 0, right? So after this step, you observe that it would be identity matrix of order 3. So this row is correct. Now concentrate to make this entry 0 as well as this entry 0. So for making this 0 and this 0, we will be using R3. So I'm writing here R2 implies R2 minus R3 and R1 implies R1 minus R3. Right? So after this operation, you will be at this step. Now, this is your identity matrix. Now you need to make these entries 0. Right now? Because I need normal form. Normal form was like that, IR or 0. IR 0 means this is identity matrix of this, and whatever you are getting here, that would be 0 if it is a rectangular matrix. Or it is a square matrix, so it may be like this. Whatever order is given and same identity matrix of same order you are getting. Or this might also happen. Identity matrix है 2 cross 2 की, बाकी सब 0 हो गया. Or this form. These all are what? These are normal forms. In normal form, there would be only entries of identity matrix and rest of the entries would be 0. So after making this identity matrix, my next target is make this entry 0 or this entry 0. In short, this column must be 0 because you have obtained here identity matrix of order 3. So now next target is make this entry 0 and then this entry 0. So for making this 10 0, because it is a normal form, you can use row operation as well as column operation. So you need to make this entry as 0. So I can take help of which column? Yes, anybody?
मैं 1.
C1.
C1, right. So for making this entry, we are using column 1. So C4 implies C4 minus 10 times of C1, right? So after applying this, 1, 0, 0, 0, 1, 0, 0, 0, 1. Now C4, 10 minus 10 time of C1, that is again 0. This is 4 and then again it is 0. Now next is you need to make this entry 0. For this entry we will use which column?
C2.
C2, right. So for this you will be applying C4 implies C4 minus of 4 times of C2, right? So this would be 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0 and 0, right? That means if I correct it in this matrix like this, you are at this step. Right? So now I can write this is identity matrix of order 3. So I can represent it like this. I3 And this whole column, zero column, can be represented by 1 0, right? So either you can leave this matrix as it is, or you can represent it in this form. There is no issue, right? After getting this, order of this identity matrix gives you the rank of given matrix. So this is what it is, a required normal form of given matrix, and then order of this identity matrix will give you rank of given matrix, right? So you are applying this and you are at this, which is in normal form containing identity of order 3. Hence, the rank of given matrix is 3. I hope it is clear. Again, I'm repeating. What is the normal form? Normal form means you need to convert the given matrix in the form of identity matrix. Order may be same or less. That depends upon your calculations, right? So you need to make given matrix into identity matrix using elementary row operation as well as column operation. When I'm saying elementary operation, it means you can use row operation as well as column operation. So after using elementary row operations or column operation, you are converting given matrix into such type of matrix, right, which includes identity matrix of order may be equal or less. After reducing into normal form, whatever order of identity matrix you are getting, that will be the rank of given matrix, right? Any doubt till here? Any doubt?
No, ma'am.
No doubt. Okay.
No, ma'am.
So this is your homework, beta. Please note it down. So till now we have covered, everyone is able to find the rank of given matrix. Then you can find the inverse of a given matrix, and then you can find the normal form of given matrix, right? Or you can find the rank of given matrix using normal form, right? Everyone? After that, next is solution of system of linear equation. Solution of system of linear equation. So you have done, everyone has done how to solve the system of linear equation. I think you have done grammar rule, right? And you can find the solution of system of linear equation using graphical also, right? But here we will do solution of linear equation system using rank, right? If you are applying the grammar rules, let us have 5 equations with 5 variable, or six equations with 6 variable, so it would be very difficult to find the determinant. Am I right? For applying the grammar rule, you need the determinant. करते हैं ना ऐसे, find the determinant and then change the first row, first column, then second column, then third column, but every time you need to find out its determinant. So if you are dealing with a system of equation, or system is containing 6 or 7 equations or more than 5 equations, then it would be very difficult to find the determinant. So in that case, solution of linear system equation using rank would be very helpful, because in that case you will applying the row operation. You are reducing your coefficient matrix into echelon form, right? So let us have, first of all, what is the linear equation system? So we do have two types of linear equation system. One is non-homogeneous system of equation, another is homogeneous system of equation. What is a non-homogeneous equation of system? If you are having equation of type this, a11x1 plus a12x2 and so on xn up to is equal to b1, Similarly, you will be having m equations with n unknowns. M equations with n unknowns, and a right hand side of all equations are non-zero, then system is known as non-homogeneous system of linear equations. For example, if I'm taking your this x plus y plus z is equal to 2, 2x plus 2y plus 2z is equal to 6, or x plus 2y plus z is equal to 4. This is what? Three equations with three variables, and right hand side of equations are non-zero. So this system is known as non-homogeneous system of linear equation, right? And if right hand side of every equation is equal to 0, if right hand side of every equation is equal to 0, then system is known as homogeneous system of linear equations. Right? Is it clear? If right hand side of every equation is equal to 0, then system is known as homogeneous system of equation. And if it is not equal to 0, then system is known as non-homogeneous system of equation. Right? So we are at this. M equations with n unknowns. M equations with n unknowns. So you will write A matrix A. What is matrix A? Matrix A is your coefficient matrix. Coefficient means this A11, A12, A13 up to A1n. So in this case, in this scenario, coefficient matrix is A11, A12, likewise up to A1n, A21, likewise up to A2n, and similarly here AM1, AM2 up to AMN. Right? So this is your coefficient matrix with order m cross n. Now, next is X. What is this X? This is a column matrix of unknowns. So I am writing here x1, x2 up to xn. What is the order of this matrix? N into 1. N number of rows and 1 is 1 column. So now when you will read it out, A11, when you are multiplying it, A11 x1 plus A12 x2 plus A13 x3, likewise A1n into xn is equal to, so right hand side again a column matrix with B1, B2 up to Bm. Right? And what is the order of is m cross 1. So now when you're multiplying it, a11x1 plus a12x2 plus a13x3 up to a1n into xn is equal to b1. So it would become your first equation. So similarly second and so on. So this linear equation system can be represented in the form of matrix. So this is the representation in the form of matrix. Right? Similarly in the homogeneous system. In homogeneous system, right hand side is equal to 0. So your equations are like this. M equation with n unknowns and right hand side is 0. Then the system is known as homogeneous system of linear equation. So again you will write the coefficient matrix with order n cross n, then unknown n cross n1, and that is equal to null matrix because all entries are 0. So it would be null matrix. So this is the representation of given linear equation system into matrix form. Is it clear? Any doubt? Any doubt? Okay.
No, ma'am.
No, ma'am.
Okay, beta. So now this A is what? That is your coefficient matrix in which you are writing coefficients of all variables. Now another matrix that is represented by A as augmented matrix. In augmented matrix, you write this is coefficient matrix as it is, then colon entry of right hand side of equation b1, b2, b3 up to bn. This entry b1, b2 up to bn. So a matrix in which we're writing first coefficient matrix, then colon b1, colon b2, colon bn. This is known as augmented matrix. Right? So what is the difference between coefficient and augmented matrix? In augmented matrix, there is a one more column of right hand side entries. If you have a system of equation like this, right? And you need to write the coefficient matrix. So what you will do, you will just take the entries of coefficients of x, y, z and write coefficient matrix like this. 3, minus 2 and 5. Minus 2, 1, 4. Then 1, 4, minus 7. So this is your coefficient matrix. Now, if you need to write the augmented matrix, so what it would be? Coefficient matrix as it is first 3 minus 2, 5. Then you will be putting 2 colon and then right hand side entry that is 3. Minus 2, 1, 4 colon minus 2. Then 1, 4 minus 7 colon 1. So this is your coefficient matrix and this is your augmented matrix. Please don't be confused with coefficient matrix and augmented matrix. This is your coefficient matrix and this is your augmented matrix, which is represented by this. Right? So this is your augmented matrix. Now, consistency of system, that means existence of solution. When the system of equation has one or more solution, that means system has unique solution or system is having infinite many solution. In both the cases, you will be saying that system is consistent, right? And if system has no solution, then that is known as inconsistent system, right? So consistent means existence of solution, inconsistent means there is no solution. If a system has unique solution or infinite many solution, then you will be saying system is consistent, otherwise system is inconsistent. Now, when system is inconsistent, system has no solution. So what is the criteria for having no solution? Using rank method, if rank of coefficient matrix is not equal to rank of augmented matrix, then system has no solution. If rank of a given matrix is not equal to rank of a coefficient matrix, then system has no solution, right? And if rank of a coefficient matrix is equal to rank of augmented matrix, then system has solution, right? Now, if both are same, then there are two conditions. Whether this rank is equal to number of variable or less than number of variable. If it is equal to number of variables, then system has unique solution. If both are equal but less than number of variable, then system has infinite many solution. But in both cases, system is known as consistent system, right? And if rank is unequal, then system is inconsistent, right? So that's all for today. Tomorrow we will start with the system of linear equation, right? But you need to remember all these conditions when system is consistent, when system is inconsistent. First of all, I ask all these questions from you all, then we will move further, right? So that's all for today.